So part C, we are going to talk about verifying inverses, okay? When we are verifying inverses, we use what's called composition. So we're using composition, and we've done composition before. We did this in the fall. And what that means is I'm putting a function in a function, okay? So I'm plugging in one function. So I'm putting in apples, turning it into lemons, and getting out some oranges. Crazy, right? I know, sounds ridiculous, but that's ultimately what's happening. I'm putting in one thing into another thing, and they're producing something all new, okay? Essentially, it's like your parents. One parent put in one thing, another parent put in another thing, and bam, here you are. That's what composition is, okay? So we're gonna talk about verifying. So how do we verify? Using composition to show that f of x equals x squared plus 7 with the domain restriction that x has to be greater than or equal to 0, and g of x equals x minus 7 are inverses, okay? So to prove that they're inverses, we are going to do composition. So we do two types of composition. We're gonna do f with g of x plugged in, and we want it to equal x. Then we're gonna do g with f of x plugged in, and we want it to equal x. If they both do not equal x, then they are not inverses of each other, okay? If they both do not equal x, then they're not inverses. So first one, so we're doing f of x composed of x plus 7, x plus 7 composed of the square root of x minus 7. So for this one, that means I am taking this square root and plugging it in for x. So we have f x minus 7, which would equal the square root of x minus 7 squared plus 7. What happens when you square a root? It goes away. It's the key that sets everything free. So when I have a square root and a square, they cancel each other out. And I'm left with x minus 7 plus 7. And what happens to my negative 7 and my positive 7? They cancel each other out, and I'm just left with x. So this side worked. So then I'm going to test it on the other side. So I have g composed of f of x equals x. So now I'm plugging in this. So we have g x squared plus 7 equals the square root of x squared plus 7 minus 7. Okay, this equals the square root of x squared plus 7 minus 7. What happens to my 7s? They cancel out, so I'm left with the square root of x squared. And the square root of x squared is x. Since this is true, then we can say that f of x and g of x are inverses. Whoop, whoop, whoop. We're so smart. All right. Cool. All right, let's try another one. Now, again, if these hadn't came out to equal x, they wouldn't be inverses, right? You got that? So here we have x minus 1 squared, and we have the square root of x plus 1. So we're going to test. So we're going to do f of g of x first, which means that I am plugging in f of the square root of x plus 1. So I plug that in, and I have square root of x plus 1 minus 1 squared. What happens to my 1s? They cancel. And we're left with the square root of x squared. What does the square do to the root? Cancels it. It's the key that sets it free. All right, that side checked out. Now we're going to do g with f of x plugged in. Mhm. Because it was part of the original function. See how it says -1? So you have to use that because you're just substituting in this for what x was. So this used to be x, but now it became the square root of x plus 1. And that -1 was already there. Now we're doing gf of x. So we have g composed of parenthesis x minus 1 squared. So we're going to plug this in for x. So where x is. So underneath the square root, I now have x minus 1 squared. Outside the square root, there's already a 1, and that 1 has to be there. A square under a square root cancels each other out, and I'm left with x minus 1 plus 1. What happens to my 1s? Cancel, and I'm left with x. Yes, so that means that f of x and g of x are inverses. Okay, so here, putting it all together, your parts A, B, and C, at this point, you should be able to find the inverse of the name and domain and range of each one of these, okay? So this is gonna be your due now for tomorrow. So if you wanna get a head start on it, make sure you complete it and have it done. So we'll have this ready to go. Cool? All right.